Hello again. Welcome to lesson 37, I believe. Chemical and physical changes, or physical and chemical changes. I've included this slide in the Google Classroom. I've also included another slideshow on physical properties, chemical properties, physical changes, chemical changes as well. That's a little more basic. You can look at that as well. So there's a couple things to do today. We're going to go through this slide, and there's a video at the end of it that you can watch. Then there's two sheets, and I'm going to kind of give you the answers for those sheets, but I'd still like you to take a picture of them and submit them to me just to show that you're working along with me. And I'm going to try and help you out and give you some answers for this one. We can kind of work our way through it. So physical and chemical changes. In a physical change, the material remains the same. That's very important. Even though its state or form has changed. Solid dry ice, carbon dioxide, can change its state from a solid directly to a gas, but it's still just carbon dioxide. It looks different, but it's still the same chemical thing or the same molecular thing. If the carbon dioxide vapor is collected and cooled enough, it will return to a solid dry ice. Dry ice changing state is a good example of a physical change. A good test for a physical change, this is important, is to see if you can get it back to the original state. You've got to think about that. Example, right? Ice, you could boil water, freeze it, put it in a glass, switch it around, but it's still H2O. Nothing has changed chemically. It's not H2OC, you haven't added carbon, or you haven't made it H1O or something. You haven't created an instant. It's the same thing, H2O solid, H2O liquid, H2O gas. It's just a physical change. You can reverse it even. Now, a chemical change, there's some signs. If you see any of these signs, you know a chemical change has happened. So let's just take a look at this. In a chemical change, the original substance is changed into a new material that has new properties. Chemical changes include burning, rusting, and cooking. You can't uncook an egg, can you, folks? You can't unburn a paper. You can clean the rust off, but the rust still happened. In each of these examples, it is difficult to return to the original material. Once a piece of wood burns, the ash cannot be converted back to wood. This inability to change back to the original components is a characteristic of chemical reactions. All right. Signs of a chemical change. These are clues you can look for in word problems and things like that. Has there been a color change? Has heat or light been given off? Did bubbles form? Did a solid form? Is the reaction reversible? Those are things that you need to think of for a chemical change to see if it occurred. This video I've included in the slides as well, but this guy slacks some lime, I believe, or some calcium carbonate, and he does a little experiment. It's pretty cool, and he makes a change and then he reverses it, which is pretty amazing. You don't think it's going to end up the way it does, so you're going to watch this video. It's a great little video. Another thing I'd like you to take a look at if you get a chance is just this other slide, physical and chemical change. I can just quickly go through that, but you could see some signs of a chemical change. Chemistry of cookies. Another great video on a chemical change, and this is included in the Google Classrooms that you can watch this. So you can take a look at those. Some good stuff there, right? Some things about physical changes as well. So similar kinds of things. Now, this gets us to the work that you need to do today. So you've got to go into your booklet, and you'll see a page after the slides that look like this. Identifying chemical and physical changes. And I'm going to do some of these with you now, but I still want you to take a picture of it, okay? All right, so water boils. I would say that's physical. You might say why. You can fill that out, but it can return to its original state. Silver spoon tarnishes. That's like a rusting. Color changed, right? Something changed color. Aluminum pot is put on a burner and gets hot. That's just a physical change. Nothing new has been created. Dry ice goes from a solid to a gas. That's just physical. And you can put why, right? Because it can return to its original state. An iron rod rusts. That's chemical. There's a color change. Gold melts or solidifies. Sorry, that's just changing the state from solid liquid to gas, right? That's just a physical change. It can return to original state. Sand is mixed with salt. That's physical. We haven't mixed them chemically. It's just a jar of sand and salt. You could separate them back, right? You could return to original state. Can be separated. Methane burns, sorry, that is a chemical change because it's produced heat and light. A piece of chalk, well, that's just a physical change. You could remake that chalk or reform it. Nothing has changed at the chemical level. An antacid tablet neutralizes stomach acid. That is a chemical change. It changes the state of the acid and bubbles will form. Glass breaks, that is a physical change. Even though like you can't really remake the glass, it is still glass. Nothing new has been created. It's just smaller pieces of glass. And yeast is used to make carbon dioxide in bread and causes it to rise. That is a chemical change, right? It has produced gas, you could write there. And a lump of sugar dissolves in water. That is a physical change because you could separate or dry out or dehydrate that and get up to just having water and sugar again if you separated them. Now on the back side, if you'd like, and I want you to do these, you do have to write the explanations there. I've kind of given them to you, but you can write those down on your own. On the back side, you can take a look at this, and I think this is pretty nifty. You are given 2 white liquids, each in a container. You are told one is milk and one is lime water, in which carbon dioxide has bubbled through and formed a precipitate. So they both, look, if you watch the video that I just told you with the guy in the lab, he made lime water and it looks like milk. So you're told one's milk and one is lime water. Describe how you could show which container had lime water and which had milk. What you could do is you could add more carbon dioxide, CO2, and look for a change. You could just add a little more carbon dioxide by blowing bubbles into it and see what happens. You could observe precipitate the hard part. Sorry, my bad. Precipitate on the bottom. Or you could leave it overnight and see if one goes sour, and you could smell it after because it would be going through a chemical change. And a concept map for pure substance using the terms atom, molecule, compound, and element. How would you put this? Well, you could say a pure substance. There could be compounds made up of molecules, and elements are made up of atoms. That's all they're looking for there. Take pictures of that, and then you don't need to take a picture of this, but this sheet is really great work. If you can get through this and see if you can answer these, that would be really great. Now, guess what? You don't need to take a picture of that sheet because on the back, there's a couple more questions that you can try. I'd really like you to try them if you can and work through with the answers. Yay! So you can go and there's the answers to both sides. And if you want to work along and kind of do the answers as you get to them, that's great. So your job is to take a picture of the sheets that I went through with you and then to try the sheet that has been given the answers. So not a lot of hard work for you to do, but I hope you've gone through the slides, at least flick through them, and watch those little videos in the slides and the video that I included in the link. So go through everything, look through it, chemical, physical chains. It's not a hard concept. And we're ready to move on to the unit test review. So we'll see you soon. Submit the picture and we'll see you soon.